All right, homework 3.5 is how the AP test, all the different questions it asks you. Almost always on the AP test, they will give you a graph of f prime, or a table that's f prime, or a function that's f prime, and then the questions will not be about f prime, they will be about f of x. So let's look at some of these things, and we want to make sure we can interpret them. It says, what are the critical values of f of x? The critical values of f of x are when f prime of x is equal to 0 or undefined. So all we're looking for is where f prime of x is 0 or undefined. Here's our graph of f prime of x. Boom. This is where f prime of x is equal to 0. At x equals 1 and x equals 4, because f prime of x equals 0. Where does f have a relative maximum? F has a relative maximum when f prime changes from positive to negative. And the reason this creates a relative maximum is because if f prime is positive, f was increasing, and then if f prime becomes negative, f is decreasing. So f prime changes from positive to negative nowhere. There is nowhere on this graph that f prime changes from positive to negative. For what values of x does f have a relative minimum? Well, now f prime changes from negative to positive because f of x would change from decreasing to increasing, and so you'll end up with a relative minimum value at the bottom of that. F prime changes from negative to positive. Here's f prime. F prime changes from negative to positive right here, which means that f changes from decreasing to increasing right here. Okay, so at x equals 4, because f prime changes from negative to positive. Where is f increasing? F is increasing when f prime is greater than 0. Let's look at how we would write this sentence. F is increasing when f prime is positive. F prime is positive only on this interval between x is 4 and x is 5. So let's see how we write this. F is increasing on the interval from 4 to 5 because f prime is positive on this interval. It's the only place f prime is positive. Okay. Where is f concave upward? F is concave up when f prime prime is greater than 0. But they didn't give us f prime prime. They gave us f prime. So you can't use f prime prime to justify your answer. You need to talk about f prime. Well, how can you tell if f prime prime is going to be greater than 0 based on f prime? Well, f prime prime is the derivative of f prime. So what we really want to know is, when is the derivative of f prime greater than 0? The derivative of this is f prime, the derivative of this graph is above 0 when this graph is increasing. So another way to think about f prime prime being greater than 0 is f prime is increasing. Because when f prime is increasing, the derivative of f prime is positive. So we're looking for where is f prime prime, or where is f prime increasing, and that's everywhere between -1 and 1, and everywhere between 3 and 5. This is where f prime is increasing, and so f prime prime is concave up, or f prime prime is positive. Okay, the equation of the tangent line at x equals 2. This is going back to old stuff here. We need y equals m times x minus x1 plus y1. So it's x minus 2, because that's where x is 2. We need the y value, and this is not a graph of f, so it doesn't tell us any of the y values of f. They're kind of sneaky here. They hide it right here. F of 2 is -6, so that means y is -6. And the last thing we need is, what is the slope when x is 2? And we get the slope from f prime. So we need f prime of 2. F prime of 2 we get off of the graph. F prime of 2 is equal to -1. So y equals -x minus 2 minus 6. Okay. Let g be a function defined by g of x equals x f of x. Find an equation for the tangent line to the graph of g at x equals 2. So we've got y equals m times x minus x1 plus y1, and it's to the graph of g, so at x equals 2, it's x minus 2. We need the y value of g, because it's tangent to g. So we're going to plug in 2 into g. G of 2 equals 2 f of 2. And again, it told us in that box up here that f of 2 is negative 6. So g of 2 is 2 times negative 6, which is negative 12. So y1 is negative 12. So when x is 2, g of x is negative 12. And we also need the slope of g. So this isn't f prime. We're looking for g prime. G prime of 2 we need to get by doing the derivative of g of x. And I really hope, that all of you immediately when you see that you're doing the derivative of g did the product rule. G of x equals the derivative of the first, which is 1, times the second, plus leave the first alone, times the derivative of the second. So g prime of 2 is equal to f of 2 plus 2 f prime of 2. Okay, again, f of 2 is negative 6. It tells us that in the paragraph. Plus 2 f prime of 2 is from the graph. F prime of 2 is negative 1. We need to be fluid with what these things mean. So negative 8. So g prime of 2 is negative 8. And so y equals negative 8 x minus 2 minus 12. It brings together a lot of things we've done this year, and you want to be pretty good at all of these. I'll do one more and make sure we know what's going on here. I love number 4 here. I think it's a great question. The graph of f is shown in the picture. So this isn't the derivative. This is the original function. Which of the following is true? F of 2 is less than f prime of 2 is less than f prime prime of 2. All these, they're just comparisons between f of 2, f prime of 2, and f prime prime of 2. So let's see if we can find them. F of 2 is equal to 0. It's just the y value. F prime of 2 is the derivative at x equals 2. And we don't know what the slope of the tangent line is at x equals 2 because they don't give us any numbers or any additional information. But it's positive. It's a positive slope, and that's bigger than 0. The last thing is f prime prime of 2. The second derivative of a function tells you the concavity. This function is concave down, and so f prime prime of 2 is some negative number. So the smallest thing here is f prime prime of 2, which is less than f of 2, which is less than f prime of 2. So the answer is D. Hopefully that helps, and you can do the rest of your homework on your own.